Now we're going to do problem 9. Problem 9 asks to find the second derivative of f of x equals 2x divided by 1 minus 3 of x. Okay, in order to solve this, we're going to have to use the quotient rule and the chain rule. So the quotient rule is right here. Recall, you have a function, it's equal to a function divided by another function. The derivative of that is the derivative of the numerator, the functions in the numerator, times the function in the denominator minus the derivative of the function in the denominator times the function in the numerator, all that divided by the function in the denominator squared. And during that process, when we find the second derivative, we're then going to have to do the chain rule. So if you have a function that is a composition of functions, the derivative of the composition of functions is the outer function times the derivative of the inner function. Alright, so let's go ahead and work this out. So first of all, we're going to find the first derivative. So f prime of x. Alright, to find the first derivative, we're going to go ahead and apply the quotient rule. So what the quotient rule says, take the derivative of the top, so the derivative of the top is going to be 2. Okay? Times the bottom. Minus the derivative of the bottom. The derivative of the bottom is minus 3. Times the top. Alright, all that divided by the bottom squared. Okay, let's go ahead and do some algebra to simplify this before we go ahead and compute the second derivative. Alright, so we can go ahead and distribute this. 2 minus 6x minus minus positive plus 6x. 3 times 2 is 6x. Divided by 1 minus 3x, all that squared. Okay, so we can go ahead and cancel this 6x with this 6x, and then we're left with f prime of x is equal to 2 divided by 1 minus 3x squared. Alright, so we can go ahead and use the quotient rule again, or we can just move this up here and have with a negative exponent. So what I'm going to do is I'm going to move this here with a negative exponent. Okay? So we have f prime of x is still 2, 1 minus 3x, and negative 2. And you'll see why I did that. So we can go ahead and take the second derivative of this now, because that's what we need to find. We need to find the second derivative. Alright, so to find the second derivative, we go ahead and take the derivative of this. Okay? So I'm going to just go ahead and say f double prime of x is equal to, okay, the derivative of this, 2 is a constant, so you can just move that aside. Take the derivative of this. But this right here is where the chain rule comes in. Because you have a function, you have an outer function, and you have an inner function. So the chain rule says take the derivative of the outer function. So the derivative of the outer function is the negative 2. So we have this 2 that we moved aside, so just leave the 2 there. Bring the negative 2 down. 1 minus 3x. Okay? Negative 2 minus 1, negative 3. Okay? Times the derivative of the inside, which is just minus 3. Okay? Now let's go ahead and simplify this. Okay, so we have f double prime of x. So we have f double prime of x. 2 times negative 2, negative 4, times the negative 3 is a positive 12. Okay? Divided by, so we have this raised to a negative exponent, so we can just bring it down. That's why I have the division there. It's going to be 1 minus 3x cubed. And that is your final answer. That is the second derivative. So to go ahead and go over this again, we're asked to find the second derivative given that function. So we must compute the first derivative. In order to compute the first derivative, we got to use the quotient rule, which we did. So the quotient rule was used up to here. So this one line is just the calculus. The rest is just algebra. Canceled out. Put it to this form, then put it to this form. So right here, we went ahead and applied the second derivative, which is right here, one step. The calculus is done. Then it's just algebra. And we obtain f double prime.